Okay guys, welcome to the class. So today we are going to go back to a bit of Form 4, Chapter 3, Chemical Formulae and Equations. For those of you who need some assistance in the basics, let's go through it. So in this chapter, you'd want to learn how to do three things. First, calculations. Second, how to write chemical formulas or formulae, and equations. So we'll start with the first and the most important one, which is the calculation. Now we'll keep it simple. For the calculations of this chapter, you need to know what is right in front of you right here. Now, in the calculation for chapter 3, the most important thing that we have to talk about is mole. Now, I won't go into too much detail. I'll just go through what is important for calculations. First, in terms of all the meanings of what is mole, we'll talk about that at another time. All right. So first things first, we must learn the function of mole and why do we need it. So the reason why we have mole is in order for us to link all three of these different units that we are going to talk about soon. So sometimes in a question or in an instance, let's say we have a substance, right? Let's just call it substance X for now. Let's say I have the mass of substance X. Let's say I know that, oh, substance X has a mass of 2.4 grams. I have a sample of substance X with a mass of 2.4 grams. Now, the question here is, if I have the mass of this of the substance, am I able to find the volume of the substance? Or am I even able to find the number of, let's say, particles in the said amount of substance? Now, these two other values can be found if you have mole. You see, in chemistry, there is no direct way for us to actually change mass directly to volume. No such way. And volume to number of particles, we actually don't have any way to directly convert one to another, or vice versa. So both, we can't do this as well. All these are impossible routes. So if that's the case, how do we get volume? If we have the mass, in order to calculate volume or number of particles, we have to go through mole. So think of mole as your bridge in calculation. If you want to get volume and you have the mass, you need to take your mass, convert it to mole, mole convert to volume. If you do this, this is actually pretty easy to calculate. So let's go one by one here. Now, if I have the mole, or let's say I have the mass of the substance, and I want to convert it to mole. Now, I can do this, but I need to have something called the relative atomic mass or the relative molecular mass. So to keep it simple, if I have the mass of a substance and I want to convert it to mole, I must divide it with the RAM or RMM of the substance. RAM stands for relative atomic mass. RAM stands for relative molecular mass. We'll talk about those two later. All right. So I've put here an arrow. Mass, to convert to mole, you have to divide relative atomic mass. Now, similarly, if you have the mole of a substance and you want to calculate its mass, you just have to multiply with the relative atomic mass or relative molecular mass. So we have a flow that we can go here. Mass to mole, divide RAM, RMM. Mole to mass times RAM, RMM. Simple. All right. Now, what if we have the mole of a substance and we want to find the number of particles of a substance? So to keep it simple, for mole to be converted to number of particles or vice versa, we need to multiply or divide something called Avogadro's constant. Oops. All right, now Avogadro's constant is actually usually denoted as n subscript a. It has a fixed value of 6.02 times 10 to the power of 23. Now this is a constant. You don't actually have to worry about it. Exams actually give you this value. So you don't have to memorize anything. You just need to know if I want to find number of particles, I have to multiply, or if I have the mole, I want to find number of particles, I have to multiply with Avogadro's constant. If I have the number of particles, I want to find mole, I just have to divide the Avogadro's constant. Simple. And the final one, if I have the mole of a substance, I want to find the volume of the substance. All I have to do is take the mole, multiply with something called STP or RTP. Now, STP stands for standard temperature and pressure. R stands for room temperature and pressure. Now, these two values again are usually given to you in the question, so you actually don't have to memorize it. So we'll see that later. They have two fixed values as well. They are also constants. So for mole, to convert to volume, we have to multiply with either STP or RTP. Volume, convert to mole, we have to just do the inverse, divide with STP or RTP. So if you have this and you keep this in your head, this is actually going to be quite simple. So I'm just going to leave this, let's call this a mind map here first, and let's try to see an example or two. Okay. So if you know these three things, calculations are going to be quite simple. So let's say I give you something really basic to start off with. Okay, so an example of a question. Let's say I tell you we have a balloon. Right? I'm not an artist, so this will have to do. All right, so let's say I have a balloon, and then I tell you this. This balloon contains 9.6 decimeter cube of oxygen gas. All right, and then I ask you, or the question asks you, to calculate the mass of oxygen gas at room temperature and pressure. Okay, now, if you want to try this question yourself, you might want to pause the video, take a look at this question, and try it yourself. If you get the answer, that's very good. So pause this right now if you want to try this yourself. Otherwise, I'm going to continue with the answer straight away right now. Okay, so let's do this. Now, whenever we do a calculation question for chemistry, my suggestion to you is always list down what is given and always see what you want. Now, in this case, the question gives us the volume of oxygen given to us as 9.6 decimeter cube. The question asks us to find the mass of the oxygen gas in grams. All right, sorry, I forgot to put it down. Mass in grams. Okay, now we keep it very simple. I'm going to give this rule to everyone right here. If you want to do calculation for SPM, they give you any value, look for mole. Don't look for anything else. If they give you the volume, you want the mass, there is no way for you to find this directly. So grab the volume, convert to mole, get the mole, convert it to mass, and you have your answer. So first thing, we have the volume in decimeter cube. We are going to find the mole first. So let's go. I'm going to put a calculation on the right side. So to get the number of mole of oxygen, now N is the symbol for mole. So we're going to go N oxygen will be number of mole equals to the volume divided by, now, either STP or RTP. All right. In this question, it says room temperature and pressure, which means that we are going to use RTP. Now, the actual value here, I'm just going to give it to you right now. If the question says STP, they usually will give this to you in exam. It will always be 22.4 decimeter cube. If they give you RTP, it will always be 24 decimeter cube. All right, so in this case, they say room temperature and pressure. So we are going to divide with the value of RTP. So we're going to take 9.6 decimeter cube, divide this with 24 decimeter cube. So if you press your calculator on this, you are going to get 0.4. Now the unit for mole will just be mole. You don't have to put anything else right there. So you get 0.4. Now that you have the mole, can you calculate mass? No problem. So now we know that to get the mass, we will take the number of mole of a substance. We are going to multiply with the relative atomic mass or relative molecular mass. Okay, so we go 0.4 times. Now, we are talking about oxygen gas, people. The REM of oxygen gas is 16. But please note that REM of oxygen is 16 means that one atom of oxygen has the relative mass of 16. Now, but in this case, we are talking about oxygen O2, which means that we actually have to consider how many atoms in the O2, oxygen gas molecule. So, since we are talking about O2, I have to multiply by 16 multiplied by 2. I'm going to put this in bracket for you. Now, this means that an oxygen gas molecule actually has 16 times 2 because we have O2. One oxygen is 16, two oxygen atoms is 16 times 2. We get an O2 molecule, so 16 times 2. So we're going to take 0.4 multiplied by 32. If you press your calculator right here, you are going to get 12.8 grams. So nothing much, pretty straightforward. This is one of the few things that you have to consider. Now, if you're a bit worried, don't worry. In exams, in SPM, every question will always give you the values of REM. They will also always give you values of either the STP or the RTP. So you don't have to worry about these values. You are always going to get it in your exam. So nothing much to worry about. All right. So people, let's try another question. So if you tried this yourself and you got it right, congratulations. If you didn't, don't worry about it. So I'm going to erase this and we're going to try another question. All right. Okay, next question. We are going to be trying something a bit simpler. So let's look at this. Now, let's say I give you this. Let's say I have a sample of a metal. All right. Let's say this is a sample of magnesium metal. All right. Let's say I took the weight of this sample and I found out that this is actually 2.4 grams of magnesium metal. All right. So I'm going to give you a few values here. I'm going to give you the RAM of magnesium. Now the RAM of magnesium will be 24. I'm also going to give you the value of Avogadro's constant, which is 6.02 times 10 to the power of 23. Okay, and let's say the question is simple. What if I ask you to calculate the number of atoms in 2.4 grams of magnesium metal? Okay, now before we continue, whenever question mentions number of atoms, atoms is a type of particle, which means that when they are asking for number of atoms, you are literally looking at number of particles. Now in exams, there may be 3 types of particles that they mention. They may be talking about atoms. They may be talking about molecules. They may be talking about ions. Exams will always specify which one they are talking about. So whenever you see any one of these three, we are talking about number of particles. All right. So if you want to try this question yourself, pause the video right now and try it out. Otherwise, I'm going to continue with the answer. Okay. So calculation goes like this. Again, look at what we have. Now, the question gives us mass. We have 2.4 grams. Question also gives us, oh, that doesn't give us anything, I'm sorry. It also gives us the other two values, RAM and Avogadro's constant. So we have the mass, we are simply looking for the number of atoms. So, very simple. You have mass, you want number of atoms. You can't convert this directly, but you can change the mass to mole, mole to number of particles. So we'll do that. So first things first, we are going to find the number of mole. N equals to, now, mole equals to mass divided by relative atomic mass. So we're going to take 2.4 grams, which is the mass, divided by the relative atomic mass. Now, for pure metals like magnesium, you don't have to consider any molecules like the earlier oxygen question, because magnesium metal exists as atoms, so there's no reason for you to multiply anything. So we're going to take 2.4 divided straight by 24. You are going to get 0.1 mole of magnesium metal. Now that you have the 0.1 mole, can we find number of atoms? Yes, we can. So I'm going to put that. Number of atoms will then be equal to number of mole multiplied by Avogadro's constant. So once you got that, I'm going to take 0.1 multiplied by 6.02 times 10 to the power of 23. If you press your calculator on this, you are going to get 6.02 times 10 to the power of 22 number of atoms. Nothing much. All right. So that is pretty straightforward. I hope this helps. Later on, for those of you who are my students, I'm going to send you a few questions. I do want you to try it yourself. Then I'll discuss the answers with you directly in your in our group chat. All right, but for now, this is the first section done. There are more complicated calculations later on, but we have to learn the formula and the equations first. So for now, I hope you're going to be okay with this. So